Okay, so I'm making this video because I'm not in class today. So this is your homework to watch the video, and you're going to need to do that. And you're also going to have to watch. There's one embedded video that will show you how to do the calculation that is required to be Dropboxed, well, submitted to Canvas online when you finish the notes. So you do have a warm up. We're mostly going to work on how to determine percent composition in compounds, but also in addition to that, you're going to be learning how to determine the amount of moles of water in a hydrated compound, better known as like the hydration number. So what is the molar mass of aluminum dichromate? So what do you need to do? First, you got to figure out the formula. So you want to dig out your periodic table, look up dichromate, look at its charge, look at the periodic table for aluminum, find where it is and remember its charge and correctly write the formula. That's the formula, right? And once you've got the formula, you can find the molar mass. There's 2 aluminum, there is 6 chromium, and there are 21 oxygens in it. You have to distribute the subscripts inside the parentheses. Now, hopefully you know how to do that. Remember, it's so important to be able to write correct formulas from words. Now, what is percent composition of compounds? We've already basically talked about this, but I just wanted to go over it quickly. It's going to be very important for the last 2 sets of notes in this class. So percent composition of a compound is the percent by mass of each individual element compared to the total mass of the entire compound times 100. So let's take a look. Total mass of the element divided by total mass of the compound times 100 equals the percent or mass percent of that particular element. Okay, now here's an example question. What is the percentage composition by mass of the elements present in glucose? So we've got 6 carbon, 12 hydrogen, and 6 oxygen. So percent by mass for each means we're going to need a percent for carbon, we're going to need a percent for hydrogen, and we're going to need a percent for oxygen. First, we got to find the total mass. So we multiply it all out, add it up, and we will have to actually round it to 2 decimals. It's 180.16 grams. That's the total mass. That's going to be the denominator of our fraction. Okay, denominator down here, right? We have to find the individual mass of the carbon, divide it by the total, times 100. It turns out to be 40%. For hydrogen, we find the total mass of the hydrogen, divide it by the total times 100, and it's 6.7140%. Where does the 5 sig figs come from? This has 5, this has 5. And then we do percent by mass of oxygen, and we come up with 53.29%. If we add them all up, okay, we add them all up, round to 2 decimals, and we end up with 100%. Now remember, whenever you're doing percent by mass of a compound, the total has to add up to 100%. Now, maybe with rounding, you'll be off very slightly. Maybe you'll be 99.98 or 99%, or you'll be 100.01 or 0.02%. Those mean that you basically did the problem right. You might have just rounded slightly differently. That also means, you know, you're going to get full credit. So don't worry if you're off very slightly. Here's another example. We got a compound. It only has 3 elements. 1 is carbon, 1 is hydrogen, and 1 is oxygen. The total mass of the compound is 45.06 grams. So the sum of all 3 elements is 45.06 grams. Now, the compound is known to contain 24.02 grams of carbon and 5.04 grams of hydrogen. What is the percent composition? So percent by mass of all 3 elements in the compound. Well, this is what you got to do. I want you to think about it for a minute. See if you can figure it out in your head. This is how you do it. The percent of carbon plus the percent of hydrogen plus the percent of oxygen has to equal 100%. We can find the percent of carbon by taking the mass of carbon divided by the total times 100. We can find the percent mass of hydrogen, again, by taking the mass of hydrogen divided by the total times 100. Then we'll have two percentages which we can subtract from 100 to find the remaining percentage, which is the percent by mass of oxygen. So that's how we get our answer. Hopefully you were able to do it. You should probably have paused a little, and then tried it. Now, hydration number. What the heck does hydration number mean? So some ionic compounds actually have holes in their crystal structure large enough to hold water molecules. Okay? That means they are a hydrated ionic compound in the normal state that you would, buy them from a company or something. Water molecules are attracted by charge attraction to these spaces. So you got holes, water vapor in the air goes into the hole, and some of the water molecules will stick. There's only so much room though, so every ionic compound that has holes that are large enough will end up with a fixed amount. In other words, a fixed ratio of moles of water to the moles of the compound. This fixed ratio is called the hydration number. For that compound, it's written as follows. Like here's an example. This is cobalt 2 chloride with a dot 6H2O. So if you were looking at the ratio for every 6 moles of water, there's 1 mole of cobalt 2 chloride. All right, this shows the ratio of the formula. Here are the actual words. We know it's cobalt 2 chloride. Where does this part come from? It's the Greek prefix for the number times the word hydrate. Hydrate means water. So since there are 6, that's hexa, and it means it hexahydrate. Now, you have a problem that you're going to have to solve in just a minute. All right? You're going to have to determine the hydration number for a compound in a second. Here it is. Magnesium sulfate. We know it exists in association with water. The question is how much water is in the crystal. Okay? A 2.61 gram sample of hydrated magnesium sulfate was heated. That removes the water and it makes it anhydrous. Anhydrous means no water. The only thing left is magnesium sulfate. So the hydrated amount of compound weighed 2.61 grams, and after heating, it weighed 1.27 grams. How do you think you find out how much water was removed? Think about it. Now, what you're really going to want to do is watch this video. I'm not going to play the video here. You want to copy this, or if you are using PowerPoint, you can just click this directly and it'll launch the YouTube video. But otherwise, copy this, paste this into the browser. It's going to spend 5 minutes showing you how to do the math. Now, you've got the numbers here, 2.61 grams of the hydrated, 1.27 grams of the anhydrous. Watch the video, and then you have homework to do. How much water is in that magnesium sulfate? You need to determine the empirical formula. That will be explained to you in the video of the hydrated magnesium sulfate. And you got to use the data on the previous slide. Write out all your work on a piece of paper, take a picture of it, and submit it to the Dropbox on Canvas. That's your homework for today. All right? Good luck.